You know, have you ever wondered how scientists go from just a simple, that's weird moment to a discovery that literally changes how we see the world? Well, today, we're going to pull back the curtain on the mental toolkit they use. It's a journey into logic, evidence, and a few really clever tricks for dealing with the unknown. All right, let's dive in. So let's start right there with that big question. Think about it. You're out in the world and you see something. An apple falls from a tree. A weird repeating signal shows up on your radio telescope. How in the world do you get from that single simple observation to something as huge as a universal law of gravity? Well, I'll tell you, it's not magic. It's a systematic way of thinking, and it's something anyone can learn.
And that whole system really starts right here. It all begins with a pretty simple idea: how we form, and maybe more importantly, how we adjust our beliefs about the world. This is the absolute bedrock of all scientific discovery.
At its very core, science is really just a two-step dance. First, you gotta pay super close attention to the world around you. That's the whole observation part. Then, and this is key, you play detective. You try to figure out the why behind what you're seeing. It's this constant back and forth between looking and thinking that pushes all of human knowledge forward. Okay, so here's the secret weapon scientists use for this. It's called Bayesian inference. Now, don't let the fancy name scare you, because the idea behind it is incredibly simple. Just think of it as a formal, logical way to get smarter step by step. It's really just a structured way of saying, okay, based on what I thought before, and this new thing I just saw, here's what I think is probably true now. It's just a system for learning from experience.
That detective analogy we talked about? It's perfect here, right? A detective starts with an initial belief, a hunch, maybe, about who the main suspect is. Then a new clue turns up. Now, that one piece of evidence doesn't necessarily solve the whole case, but it absolutely updates their belief. Suddenly, one suspect seems just a little bit more likely and another a little less. That little shift, that's Bayesian thinking in a nutshell.
And this isn't a one-and-done kind of deal. Not at all. It's a continuous loop. You have an idea, a hypothesis. You go out and gather some evidence. You use that evidence to update your belief, and then you do it all over again. You go back out into the world to test that new, slightly more accurate belief. It's just a constant cycle of refining your understanding, getting closer and closer to the truth every single time.
Okay, so having that framework is one thing, but let's be honest. The real world is messy. It's chaotic. It's full of uncertainty. So to really navigate it, scientists need to upgrade their toolkit. And this is where things get really interesting and kind of tricky. What do you do when you have, say, 2 or 3 competing explanations for something? And what if the data you're getting is noisy or incomplete? How do you weigh all that evidence and make a smart call when you just don't have all the facts? This is where we need some more powerful tools in our belt.
One of the most powerful of these tools is a concept called entropy. Now, in this context, just think of it as a measure of surprise. How surprising is a new piece of information? For example, if I tell you the sun is going to rise tomorrow, well, that's not surprising at all. It contains almost no new information. But what if I told you there's going to be a total solar eclipse visible from your house tomorrow? Whoa, that's a huge surprise, and it carries a ton of information. By measuring entropy, scientists can literally put a number on their uncertainty.
Another key tool is what's called model selection. This is kind of like being a judge at a science fair. You've got all these different explanations, these different models, all competing to be the winner. Your job isn't just to see which one perfectly fits the data you have right now. It's to find the simplest, most elegant explanation that still does a really good job.
And as you can see here, it's often a big trade-off. So let's just walk through this. Look at Model A. It's simple, it's straightforward, and it does a pretty decent job explaining the data. Now look over at Model B. It's way more complex, with all these extra bells and whistles. But hey, it fits the data you have perfectly. So, which one do you pick? This is where that Bayesian logic comes back in. It gives scientists a mathematical way to balance that simplicity against accuracy, helping them avoid these super complicated ideas that are actually more likely to be wrong down the road. Okay, so we've got our logical framework, and we have our toolkit for handling all that messy uncertainty. So now for the payoff. Where does all this actually take us? Well, this is where we move from just theory to actually decoding the universe itself.
Seriously, we're moving way beyond simple questions now and heading straight for the frontiers of science. These tools aren't just for, figuring out coin flips or solving little puzzles. They are being used right now to tackle some of the absolute biggest questions out there.
And I mean, just look at the sheer scope of this stuff. Using this kind of thinking, scientists can understand how a system goes from being totally chaotic to perfectly orderly, like watching water suddenly freeze into the beautiful, intricate structure of a snowflake. They can map out the hidden connections inside a complex system, like how different parts of your brain are talking to each other. It's an incredibly powerful way of seeing the world.
And this quote from our source material just nails it. At the end of the day, it all comes down to connections. The whole goal is to see how the little, tiny parts of a system relate to one another and how those relationships change and evolve over time. It's about seeing the world not as a collection of separate things, but as this deeply interconnected, constantly shifting web.
So let's just pull back for a second and look at the big picture here. Because what we've been talking about isn't just a set of tools for scientists. No, it's something much, much more fundamental than that.
And this right here is the ultimate takeaway. This way of thinking, it is not just for people in white lab coats, it's a fundamental toolkit for absolutely anyone who wants to reason more clearly in a world that is just full of uncertainty. It's really about being open to new evidence, being willing to update what you believe, and just making smarter decisions in every part of your life.
So, on our little journey today, we've walked through the whole process. It all starts with a simple belief. You then test that belief against the real world, and you update it with real evidence. When you're faced with choices, you use these powerful tools to pick the best explanation. And finally,
You can use that entire logical engine to understand and decode the most complex systems you can possibly imagine.
And that brings us right back to you. Because this powerful way of thinking, of reasoning through uncertainty, it's not just for research labs. It's a tool for all of us. So the question I want to leave you with is this. What is one belief you hold right now that could be tested, refined, and updated if you just actively went out and looked for new evidence?